Hello and welcome to Nation Innovation. In this series of videos, we will be dealing with the core concepts of electronics which are asked in GATE and ESC exam. So, for example, we are taking a question from network in this video, network analysis. So, the question is, we are given an inductor of 1 millihenry and we are given the voltage waveform across it. So, which is a rectangular waveform of time period 1 milliseconds. This time period is in milliseconds. This is 0.5. This is 1. And the voltage amplitude is plus 1 and minus 1 volt. So, we have to find the current across this inductor. We have to find the current across this inductor. So we will discuss that firstly. The basic equation which governs the current through inductor, it is given by VL in inductor given by VA equals to L di by dt. This is the basic equation, the fundamental equation. So if we apply a common sense here, let's say our first approach, which we apply a common sense here, if VL here is given as rectangular. If VL is here given a rectangular waveform and inductor, of course, it is a constant 1 millihenry, then what will be di by dt? That means some waveform whose derivative is equals to rectangular. So this directly implies that di by dt must be a triangular wave, right? Secondly, if we solve it through the traditional method, then we can divide it as from time equals to 0 to 5 0 to 0.5 millisecond. In this case, plus 1 voltage is there. V equals to L. L is 1 millihenry and di by dt. From here, if we calculate di by dt, we get 1000. And if we change it into Laplace transform, then it will be S is equals to 1000 by S, or you can say Is equals to 1000 by S square. So if we take the inverse Laplace transform of this, It will be equals to 1000 times t. Similarly, if we talk about time period from 0.5 millisecond to 1 millisecond, then It will be given by 1 minus 1000 t. And there from this, we can get It as triangular wave of this will be 1 millisecond. So this It will be a triangular wave of peak. The peak will also be the matter. The peak will be here 0.5 ampere. Thank you. Stay tuned for more such videos.